Hello. This will be a set of 2 recordings. That's the plan. It will implement the single column bit adder that we've looked at in class. Actually, we've looked at it kind of scattered around all over the place. You'll recall the majority function. And then we discovered that the majority function is actually the carry out bit for a single bit adder. And then we did another example in class last week, and that was the sum bit. So this is an implementation just to show how those all come together to actually perform addition. First of all, I got to get MMLogic. And I'll go ahead and make that large. And this line right here, I don't know why they do it this way, but this line says this is the only part of the palette or the background that we can use. But you can change that. If you go to Window, no. If you go to View and Grid Settings, and I think I can widen it on this little laptop up to 1200. It'll probably be bigger on machines in the lab, but you can see it just made this window where I can draw things a lot bigger. Okay, let's get going. The first video is all the circuitry and everything. And the second video is the colorful candy shell. That'll be the interface. So stop talking and start clicking. Yes, okay. Switch, switch, switch. And those switches, I'll go ahead and label them right off the bat. We had a top bit, a bottom bit, and a carry in from the previous column. Those are the 3 inputs to our addition logic circuit, and then we'll produce 2 outputs, but you'll see that when we get there. Let me go ahead and set these properties. For now, I'll just call it A. I think I'll give it a more enlightening name once we have the adder complete, and that'll be part of setting the interface. B, and yes, okay. And this one, properties. I'm going to call this C in because we'll have both a C in and a C out. And I did that ugly. Needs a blank after it. One moment, please. There. I put a blank before and after on most of these little text boxes because it just makes it a little neater, a little more professional looking. Now, unlike the MMLogic demos that I've already done, I'm going to start off because I know both of these circuits are going to get kind of tangled up and complicated. I'm going to start off by sending these inputs to the next page. And that way that'll give me plenty of space to do a whole circuit for the sum bit and then a whole separate circuit for the carry in. Not for the carry in, but for the carry out. Yeah, my caffeine is long worn off. And I have to put this in zoomed in mode so it's easier for me to connect things. You probably don't have to do that. But if you get a shaky hand or you have trouble seeing, then maybe it'll help. There we go. And then back out. Now, while I'm still here, I'm going to go ahead and let's see. I'll do the sum bit first. That's the one that we did in class as another example of a truth table and SOP and all that stuff. And I've got the SOP here next to me, so I can use that as a reference. We did an SOP for the sum in class, and the SOP for the C out, that's the majority function, and I think it's also the previous MMLogic demo. But for now, I'm just concentrating on the sum and talking more than I'm clicking. But I need senders to send it to the next page. I need a receiver to pick it up when it comes back. And I'm going to go ahead and zoom in again and connect that like so, and give this a name while I'm here. Nice and close up. Properties, sum. I can't think of any better name than that. Now, I'm not putting blanks in the sender and receivers because those, since they have to match exactly, sender and receiver names have to match exactly, it's easier for me to remember just to type the bare minimum. And I hope I'm getting these labeled correctly to the way I did the switches. I guess I better scroll over and see. A, B, and this one, properties. I'm just going to call that CN, all lowercase. It's just easier to type. It's quicker to type. Now, that's what I have so far. Which doesn't look like an awful lot. And it isn't really. But you'll notice down here in the bottom corner, this is page 1. So I'm going to go to page 2. You click on the purple plus rather than the magnifying glass plus. Go to the next page. It looks like I erased everything, but no, I'm on page 2. Just for safety and security, there's page 1 again. Now page 2. Over here, I need to receive A and B and C. So I'll need 3 receivers. I need to give them the proper names. They have to match the senders exactly. A, properties, B, properties, CN. Those are the 3 inputs. And let me see, for the sum, I need 1, 2, 3, 4. 4 3-way AND gates. So I'm going to go ahead and dump all those down here. And I think I do need both plain A, B, C, and not A, and not B, and not C. So I'll get the NOT gates out here while I'm at it. I'm just assembling all the pieces right now. Connect everything with wires. Oh dear, close up. Oh, come on. And because I might be connecting multiple things to plane A, plane B, and so forth, I'm also going to put a node for each input and connect those with wires. Now I can connect from A or not A, B or not B, and all that stuff without having to do anything beyond just this initial setup. And you'll notice I'm doing this without even taking a single look at the SOP because I know I'm going to need all these things. The only thing I've used the SOP so far are to count how many AND gates I need, and they each need to be 3-way AND gates. So before I forget, that I did look to the SOP for. 3 inputs for you. 3 inputs for you. 3 inputs for you. Some of this is a little bit repetitious, but that's okay. And you guessed it, 3 inputs for you. Now, this next step I'm going to do without even looking at it. All the AND gates, those are the products, and then we'll need to take the sum. So I can do this without looking at the SOP. I'm going to have to gather all those up into a single OR gate. So that's going to have to be properties of 4-way OR gate. And if I needed more than 4 inputs, I'd have to cascade them. We talked about that a little bit in class. Plus, so I can see it, wires, connect the wires. Oh, come on. That makes it work when I say, oh, come on. That's why I say it so often. Okay, but without even looking, this is going to go back to the front page and become the sum bit. It's all close up. It's kind of hard to see everything. But I'll need a sender to send the sum back to the front page. So when I get this part done, I'll do an overview, and then I'll have to pay attention to the SOP to get anything else done. I'm going to set the properties of this. This needs to be called sum because that's what it was called in the receiver on the front page. Okay, back down to normal size. Here's how this is going to work, ideally. I hope so. Here's the 3 input switches, A, B, and CN. They are not going to be used here on the front page. They are sent through senders A, B, and C into the second page. They'll be picked up here and run through all the special stuff we need to connect the ANDs and the OR together, and it does all the thinking about what the sum bit ought to be. And then a sender called sum, you can send to pages forward or backward. It sends it back to the front page in the form of receiver sum 1. I'm sorry, I'm stumbling over my words. I am drinking coffee, and it's just not helping a whole lot. Okay, no more procrastination. I have got to look at the SOP to see how to connect these. Big chug of coffee. Not A, not B, C. Okay, I might as well go ahead and zoom in. I know I'm going to need to. The first one is not A, not B, and C, plain C. Okie doke. 1 down, 3 to go. The next one is not A, B, not C. Not A, B, Not C. I'm going to need to remember to jiggle these things around. This is the computer that I just got this semester. And I told you, for some reason, MM Logic likes to make things disappear between when I save and then when I reopen. So later on in the video, I'll need to remember to do that. A, not B, not C. A, that's the next product to represent. A, not B. Keep an eye on me, make sure I'm connecting the right ones. I don't trust myself. Not C. Not at this moment. This has been a pretty much a wear and tear weekend. But that's irrelevant. I'm not even trying to. It has nothing to do with the business at hand. Sorry to complain all the time. I guess that's in my nature. A and B and C. Okay, plain old A and B and C is the last one. I know. A, B. This really takes a steady hand that I don't really have. C. And yet somehow another, it looks like it's done. Zoom out. Okay, there. That should be, if I connected it and read the SOP correctly. Let me go back to page 1. File, before I forget, file, save as, and look at all this mess. Oh my goodness. Workshop, we're in workshop. Let me do 1-bit adder. 1-bit adder. Like that. 1-bit adder. And what shall I call this? This is, I'll just call it adder demo. ADDERDEMO. Okay. Now, it's been saved. It's adderdemo.lgi. Click on the diskette just to save it again. Cross fingers and hope for the best. Run. Okay, starts off, and we're doing the sum bit. A 1, so far so good. That's added these up. This is 2, should be a 0, carry a 1. That's a 1, just 1. That's 2, put a 0, carry a 1. You can check these, you can slow down the video or whatever, or pause it and check these individually. But in general, the sum bit should be on or red when exactly one of the switches is on. Because if 2 of them are on or all of them are off, then the sum bit will be 0 and we're carrying a 1 or carrying a 0 to the next column. Oh, that's not true. 1, 1, 1, that's 3. So that's put a 1, carry a 1. 2, put a 0, carry 1. 1. I think I've been through all the possibilities now. Okay, now here is where I'm going to remember before I forget. I'm just going to move everything around. This is what I was talking about in that cryptic email. Look what I'm doing here. All I'm doing is just shaking these things up. Maybe I'm shaking something loose in the mind of MM Logic, who knows. And to see if my experiment holds true, I'm going to go over here, and I'm not going to do anything to this guy down here. Let's see what happens. If I just shake this one up a little bit, shake this one up a little bit, shake your, oops, shake and bake, shake that, and I'm just going to leave it at that. Let me see. No, I'll do the nuts. I'm scared. I don't want to have to do all this over again. So the only one that's not getting shook is the AND gate down here. And you'll see what I'm talking about if this does the way I think it will. Save. It saved. I saved it. And I save it again. And I'll even go to File, Save. Now I'm going to close it. Now I got to find it. Oh dear. It's in CS1 Workshop. I remembered. Well, it's in the wrong place in the workshop. Probably put it in an old workshop. Yes, I did. 1-bit adder. You didn't see that. Okay, let me open this. There we go. Look at this. Bad wire found. Now watch. Look at this. This looks fine. Look at that. I didn't jiggle the last AND gate. I hope that you don't have to do that in the CS lab. That is just a ridiculous layer of additional complication. But oh my goodness, it took me all day yesterday to figure that out. Now I have to look at the last term of the SOP again. Figure that out was in air quotes. You didn't see it, but I didn't figure anything out. I just tried everything under the sun. And who knows why that worked and the other things didn't. I don't know. And at this point, I do not care. I'm going to declare victory and move on. Just plain OA, plain OB, plain OC, and zoom back out. Select, do the jiggly dance. There, you happy now? Okay, and save, file, save. I hope it's not totally broken forever. Go away. Okay, now come back. You probably in the lab, instead of just clicking on it, I don't think they've got the file associations yet. You probably have to do this. You probably have to search for MMLogic again. Well, it went behind the window. That was weird. Now I've got to open it from where it says, and it took me back there. And it didn't give me all those bad gate errors, so I think we're good to go. It's all there. Now, before I forget which is which, and I'm not kidding, I would definitely forget, I'm going to put a label on this. What are you? You are properties. I'll go ahead and put the final label of this. Some bit for binary addition. Ideally, the comments are useful for explaining this to people less enlightened and informed than ourselves, so that when they look at this, they know what this is all about. And that's really all the documentation I need for this, assuming that none of it disappears going from this time to the next time. Okie dokie, let's go on to the next page. And I've got to do the sender receiver thing all over again. First of all, I got to get A, B, and C. So I got something to work with. I'm headed toward the carry out bit now, if you're wondering what's going on. And I got to change those names before I forget. Everything is before I forget. Did you notice that? Before I forget, let me change this to B. Properties. Before I forget how to type, it seems like. Properties. C. Is that how I did it? I think it was CIN. Memory of a fruit fly. And on the far side, we're going to eventually send out a carry out bit. So my property there will be properties COUT, all lowercase, so I don't have to remember how to capitalize. And yet I was confused anyway. Did I capitalize or not? This is also probably going to need 3 NOT gates. This is just normal setup here. You go ahead and get your inputs, get your NOT versions of them. Zoom in if you gotta. First try. Not first try. Second try. Get some of the nodes over here. Node, 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 and connect those with wires. This is all set up, getting ready to do the circuit for the carry out bit. Okay, now zoom back out. I'm looking at the C out SOP. It's got, well, just like the sum, 1, 2, 3, 4, 4 3-way AND gates. Not every circuit we do is going to have 4 3-input AND gates. That's not right. Can't talk and click at the same time. Snippet, snippet. Okay, AND gate, come on. 1, 2, 3, 4. There could be different inputs on the AND gates depending on your SOP. There could be different numbers of AND gates. This is just a somewhat unfortunate coincidence, and I need to change them to 3-way ANDs. You know what? I'm going to concentrate on getting this done and maybe stop talking just a little bit. These have all got to be changed to 3-way AND gates. Come on. See, it worked. You got to say, come on in your irritated voice. Now then, how about connecting it? Not a, whoops, I might as well zoom in. No, wrong zoom in. Let's go the other way. Okay. Now, the first one is not A, B, C. wire, not A. Plane B. Plane C. Then the next one is A, not B, C. A, not B, not B, C. And the next one is A, B, not C. It is just not cooperating. I forgot what I said. A, B, not C. One more. If I can make it through one more. Plane A, B, C. A, and you can scroll down while you're holding down the mouse button so that it'll connect. Plane A, plane B, but you still have to connect it. Plane C. Now, those have to be all OR together, so another four-way OR here. And that's not always going to be 4. Sometimes it could be 2, sometimes it could be 6 or 5 properties. 4, okay? And connect all the AND gates. 1, 2, 3. One more. We can do it. 4. Okay. I'll scroll over here. I got to connect that to the Cout output. Now, I'm going to go ahead and put the label while I'm here. Not that. I accidentally clicked twice. And I called this one sum bit for binary addition. So I'm going to call this wishful thinking properties. Carry out bit for binary addition. There. Okay. Now, before I save and open it up, I'm going to do the jiggle dance for everybody. This may very well be an unnecessary step, but if you start having the mysterious disappearing wire effect in the lab, then remember to do this. I don't even know if we got to do absolutely all of them, but I'm going to do it anyway. Okay, back to the front. This is called Cout. I don't think I have a Cout receiver yet, but I'm about to. Here's the receiver. I'll call this one Cout, all lowercase, C-O-U-T, I believe. And they give it an LED, which is here, connect, and just so they look different, I'm going to change the color. Go to properties. The original one is red. Green, it'll be like a stoplight. Okay, go. Okay. Now, we've already tested sum, so unless I mess something up, the sum is working. We don't have to pay any attention to that this time. But the carry out's the same as a majority. So whenever 2 switches or 3 switches are on, then this light should be lit up. 2 switches, 2 switches, 3 switches, 2 switches, 1 switch. It looks like they are working. And I hope I remember to jiggle absolutely everything. I'll stop it running. So there we are. This is the digital logic for the binary adder. Doesn't look like addition, does it? That's going to be the next video. Here's the guts. I won't even need to look at that in the second video. All I'm going to do is fix up the fancy colorful interface up front. And this is all working. So as long as I jiggled everything and as long as everything gets saved, file, Save as. Now, I do versioning. There's not a way to turn on versioning in multimedia logic that I know of, but I'm going to call this demo adder underline, and let's see, what is this completed? Circuits. There. Now, when I work on this, I can open circuits and save it as something else when I put 1 and 0 and all this column stuff over here. But if I mess up just horribly, or if wires start disappearing, then I know I can go back to the previous version, which will be called, in this case, adder demo circuits. I'll show you what I mean in the next video. But for now, I think that's good for this. So I'm going to click on this and stop. I'll see you in class.